Okay, hi there. This is video number 32, and this is chapter 10, section 2. And this is all about the ellipse. So this is, remember, an ellipse is an oval, essentially, and we can have an ellipse with different orientations. So this has a lot more information than a circle, because we can have an ellipse with this kind of orientation, or we can have an ellipse with this kind of orientation, and different things happen based on that orientation. So let's talk about these guys. All right, so I'm going to kind of break this page up into, kind of bust this right down the middle. I don't know if that's going to be a straight line. Yeah, I guess there we go. We'll just kind of extend that down the page for a little bit. And so we have a couple different things happening here based on this ellipse. So this is a horizontal ellipse, where it is longer than it is tall. And this one is a vertical ellipse, where it is taller than it is wide, or taller than long, whichever way you want to put that. Okay, so there's a couple things you need to know. Obviously, they have a center, and that center for both of them is going to be at the point HK, just like a circle. Okay, they both have something called the major axis, and the major axis goes from the center to the endpoints of the longest part of the axis. So in this one, it goes this way. Oh, that was a very not straight line. Okay, so that is called the major axis. And we'll have a definition at some point in a little bit. And those at the very edges are the vertices. So this is a single vertex, and it is at the point, this one's at the point negative A0. The one over here is at the point A0. We don't really, and that's, I mean, if this thing is centered right at 0, 0, let's actually not don't put those on there, because you don't actually know where those points are. What you should know, though, is that this distance from here to here is a distance of A units long, and this is also a distance of A units long. In the vertical one, this is a distance of A units long. This is a distance of A units long. This is a vertex. And this guy's a vertex. Okay. Then on the sides, you have a distance from here to here and from here to here. These are a distance of B from the center. And these are, this is called a covertex. So is the other one. I'm not going to label both of them. Then there's these points, which are B's. That's a covertex. Top and bottom, right? So you have a vertex on each side, the long side. You have a covertex on the short side. That's going to happen for all of them. All right. So now you have the standard form of these things, and they vary a little bit. Standard form of the horizontal one looks like this: x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. Standard form of the vertical one looks like x minus h quantity squared over b squared plus y minus k quantity squared over a squared equals 1. So if you think about this, this guy is going up and down, and so the a is under the y. Notice that there? This guy over here is going left and right, and so the a is under the x. Now, there's something else you need to know for these, and that is that a is always greater than b in an ellipse. That's going to happen all of the time. Okay? And that makes sense, right? This a distance is clearly bigger than this b distance. This, and in the horizontal one. Well, in the vertical one, this a distance is clearly bigger than the b distance. That's always going to happen. A is always going to be bigger than b. Okay, so here's some formula for your vertices. This guy's going to be h plus and minus a comma k. Vertices for this one are going to be h comma k plus and minus a. So here, the a is being added to your x value. On the vertical one, the a is being added to your y value. Okay, your co-vertices. This is h comma k plus and minus b. This one's h plus and minus b comma k. Okay, the major axis is 2a units long. Same thing for this guy, no difference. The minor axis, okay, the major axis, we talked about that being the long one. The minor axis is the short one in the picture. That's 2b units long. Okay, and then we have something called foci, which actually do you even need them for varsity? I don't really think, well, yeah, they might throw something in there where you actually need to know. So the foci are these points they're always on the major axis, and I'm going to draw them here in green. They're always equidistant from the center and from the endpoints, and they have a distance c. Oh, that was supposed to be a c. It didn't look very good. C from the center. So they're on the major axis. C units from the center. Okay, so what the heck is C? Well, let's see, so what color haven't I used here yet? Red. So the foci are H plus and minus C, comma K. And the foci here are H, comma K plus and minus C. And for both of these, there's a formula, C squared equals A squared minus B squared. So if you know A and you know B, you can find C. You'll rarely be told what it is, but you can find it. Okay? Now let's do some definitions. Okay, so the vertices are the endpoints of the major axis. And they're always written as ordered pairs. Okay. The covertices. These are the endpoints of the minor axis. And these are also written as ordered pairs. The orientation is either horizontal, which means this way, or vertical, which means this way. And that's really important because your standard form, while they're almost the same, it's really important where the a squared and b squared go in that standard form. So remember, if this thing is horizontal, meaning it's longer or wider, then the a goes under the x. But if this thing goes up and down like this does, then the a goes under the y. And the a is always bigger, right? A is greater than b. So that's how you know. So there's a little bit, nope, there's a lot of information that you have to remember with these guys. So it's good that you can use your notes. Okay. So then we have the major axis. Oh, geez. Major axis. So this is the length of the longer axis, either long or tall. Let's use wide, either wide or tall. Period. I'm not going to fit that in there. And it's represented by the length 2a. Where a is the distance from the center to a vertex. And we already defined what that is. Okay, I got to flip a page here. Sorry, hope that's not too loud in the microphone. All right, and then we have a minor, that's not what I meant to do. Sorry about that. Then we have the minor, blue, minor axis, all the same words basically. This is the length of the shorter axis, either wide or tall. And this is represented by the length 2b. Where b is the distance from the center to a covertex. Okay, so now you've got a bunch of information. Let's talk about graphing one. Let's go to a new page. I'm not going to put paper on because we've got some other information. So we're going to graph x minus 1 quantity squared over 9 plus y plus 3 quantity squared over 16 equals 1. So your first job, 1, what's the orientation? Because if you don't know the orientation, then you can't really figure anything out. So the orientation, you know that a squared is great. If a is greater than b, then a squared is greater than b squared. So of these two numbers, which one's bigger? Well, it's clearly this guy. Since that's sitting underneath the y variable, then the orientation of this is vertical, which then tells me, if you flip back to that page in your notes, that the formula that I need, the standard form, is x minus h quantity squared over b squared plus y minus k quantity squared over a squared equals 1. So now I know a few things. I know the center, because it's hk, comes from here. And because those are, I kind of covered some things up. Let's move some of these circles. Let's move. Oh, gosh. Okay. Let's see if I can do that a little better. I want that green circle. All right. So we know that the center is a +1, -3. Okay. We know that b squared is this guy. So b squared is 9, which means b is 3, because I'm taking the root of it. And because it's under the x, b is under the x. When I graph, x goes left and right. So b is going to go left and right. Okay. A squared is under the y in this case. So a squared is equal to 16, which means a equals 4. And because a is under the y, a is going to go up and down. And I like to place those arrows on mine so I don't get confused. I mean, I still do that. After 20 some years of doing these, I would still do that. And once you know all of that information, that's all you really need to know in order to actually graph this thing. So let me show you how that's going to happen. Let me grab a little bit of space. I need the center, and I need this information in order to graph. So here's my graph. I'm going to plot the center. So we're going to plot this guy, 1, -3. And then I'm going to go left and right 3 units from the center. So I'm going to go 1, 2, 3, 1, 2, 3. Then I'm going to go 4 units from the center, up and down. So back to the center, 1, 2, 3, 4, 1, 2, 3, 4. And so this looks pretty round, but it's not. It's a little bit taller than it is wide. And these things are super hard to actually draw. They end up looking like footballs usually, but that would be what that information is. And if I was having you do these like as a big unit, I'm not. I'm trying to squish them in before the beginning of May. On paper, I would have you graph all these longhand, and I'd ask you a whole bunch of questions. I'd ask you to tell me what the major and minor axes are, the points of the vertices and the co-vertices, which you can get off these graphs, there's also something called eccentricity, which I'm not going to ask you to do. I'd have you plot the foci. There's a whole bunch of stuff, but we're not going to do that in varsity. So that's all you really need to be able to do in order to graph these. In varsity, be careful when you do these. You will see a picture like that and a picture like that. So make sure you pick the right one, and then just start in your center and drag out and up the number of units, and it will like over 3 and up 4, and it will create the ellipse for you. Okay. So that's how you're going to create a graph for one of those. Now, next, what if you see this? If you're given 25x squared plus 4y squared equals 100, and you're told to graph it. Okay, well, first, the big deal with these equations, if we go back to our originals and the equations, I'm going to go back one more screen. Oh, okay. So these things have to always be equal to 1. Always be equal to 1. No matter what the orientation is, they have to be equal to 1. So if they're not equal to 1, the first thing you need to do is divide by whatever this number is so that they are equal to 1. And if you divide by that on one side, you have to divide every term by that. Okay, so then we're going to reduce. So we're going to divide and reduce. And now 25 over 100 is 1/4. 4 over 100 is 1/25. And this is the standard form of an ellipse. And where's the center? Oops, C-E-N-T-E-R. There we go. If there's no sets of parentheses here, then the center is at 0, 0. Okay. My orientation of this thing, because this one's bigger, the orientation, this one's also vertical. So this is my a squared, and this is my b squared. So my a squared equals 25, which means a equals 5. B squared equals 4, which means b equals 2. And then if you were to graph this thing, let's pull a graph down here. Then, oops, move that over just a tiny bit. Then I'm going to plot this in the middle. Now, A is my Y, so A is going to go up and down again. B is going to go left and right. So up and down 5, left and right 2. So you can see this one is much more elliptical, which is, I mentioned eccentricity a minute ago. The eccentricity actually verifies the roundness of an ellipse. So we don't need to really talk more about it because we're not going to use it because we're using varsity. But if we were doing a different, getting a little more in depth in this unit, we would be talking about that. Okay. General form. So, general form of an ellipse is ax squared plus by squared plus dx plus ey plus f equals 0, where a does not equal b. Can they ever? No, they can't. Where a does not equal b, but they must have the same sign. Meaning they're both positive or both negative. So that will not necessarily be the case when we do a hyperbola. Remember, when we did a circle, A had to equal B. So, and they were also the same sign. I didn't mention that, but they do have to be the same sign in a circle as well. This is an H. It does not look like one. Okay, so let's do this problem. Given 4x squared plus 16y squared minus 8x minus 96y plus 4 equals 0. Put it in standard form. And we'll just stop there. We won't talk about actually graphing it at that point, but you'll probably have to do that in varsity. All right, so we're going to do this exactly the same way we did with a circle. We are going to, 1, group our x's and y's. Then 2, we're going to take out the GCF and put in blanks. 3, we're going to fill in the blanks. Remember, that's 1/2 of b squared, just as a reminder, because you haven't done a ton of this yet. 4, we're going to turn our perfect square trinomials into perfect square binomials. And in this one, after we do that, let's see what our last step's going to be. All right, so first step, let's group our X's, group our Y's, and remember, move this guy to the other side. Excuse me. Now, factor out your GCF, only the number, not the variable. So we're going to take out a 4 minus 2x plus a blank. We can take out a 16. That leaves us 6y negative 4 plus a blank plus a blank. Okay, so remember that the blank is 1/2 of b squared. Well, in this case, 1/2 of b is 1. Squared is still 1, and that goes there. However, 4 times 1 is what goes over here, right? Then here, we're taking 1/2 of 6 squared. 1/2 of 6 is 3. Squared is 9. That's what's going here. And then 16 times 9 is what's going over here, which is 144. Excuse me. Okay, so now perfect square trinomials in parentheses. So the perfect square binomials. So we're going to bring down our leading coefficients. Binomial squared, bring down the coefficient, binomial squared. Do the math over here. So these are going to cancel each other out, leaving us 144. And remember to do the binomial squared. Take the root of this guy. Root of x squared is just x. The sign off the b term, which is negative, and the root of the c term, which is 1. Then for the y's, we're going to do the root of y squared, which is y. The sign off the b term, which is negative. The root of 9, which is 3. Okay. Now, in the circles, remember our coefficients. I'm going to highlight these. You should not. In the last section, these were exactly the same, and that's what we divided by. Well, that's not what the case is going to be here. In this one, this number has to be 1. So what we're going to do in this case is we are going to divide by the value on the right of the equal sign, because that has to be a 1 every single time. So we've got to turn that into a 1. We're going to divide that and divide that. So now when you do this, let me grab the highlighter again, a different one. These numbers are just going to get reduced. So 4 over 144, 16 over 144, and 144 over 144. Well, that one's straightforward. So I've already got these prepared. 4 goes into 144 36 times. So this becomes x minus 1 quantity squared over 36. My plus sign comes down. 16 goes into 144 9 times. So this becomes y minus 3 quantity squared over 9 equals 1. And here is the standard form for that ellipse. Now, here's the questions you would typically have to answer. Where is the center? What is the orientation? And if you were going to graph, we would want to know what is a squared, what is b squared. So let's do that. What is the center of this thing? You fill it in. It's going to be 1, 3. The orientation, this one's going to be horizontal because the a squared is 36 and it's underneath the x. So the a is going to be 6 and it's going to go left and right. B squared is 9. So B would be 3 and it would go up and down. And if you were going to graph this thing, that would be all the information that you would need to actually do that graph. All right. Last thing we need in this video It's just they throw you something a little bit different your last two questions in varsity. And I think if we do one, you can do the other one. So the question says, write an equation of the ellipse that has a center at the origin and a focus at 0, 4. This is the singular of foci, by the way. Focus at 0, 4. And a vertex at 0, 6. Okay, so that's all the information they give you. So the best thing that I would tell you is to draw a picture, because that will give you some information. So I'm going to throw a coordinate plane on here just to help us. And here's what we know. We know the center is at the origin, right? Which means the center is here. A focus is at 0, 4. And remember, I mentioned the focus is C units. From the center. Okay, we mentioned that earlier. So if that's at 0, 4, that means that's there. So what that tells us is a couple things. You also know the foci are on, oh gosh, get back there, on the major axis. So this tells us that the orientation of this ellipse is vertical. And C equals 4. We know that because it's 4 units away from the center. Okay, so this piece of information tells us a ton. It tells us about the orientation, and it tells us about C. We also know we have a vertex at 0, 6. Well, remember, a vertex is A units away. So a vertex is A units away, so we also know that A is 6. Okay, so we need to fill in if the orientation is vertical. Here's why this is so important. We know that we need to fill in x minus h quantity squared over b squared plus y minus k quantity squared over a squared equals 1. I want to know what formula I have to fill in right from the beginning. And so if I'm you, I'm going back to the very beginning of my notes, which I'm going to do. I'm jumping back there. And I want to know which of these two formulas do I need to fill in? Okay, which of these two formulas am I filling in? Am I filling in the horizontal one or am I filling in the vertical one? Well, that's based on the information that you have. They're not telling you. So you need to figure that out. So we know we need the vertical because of where these points lie and the information that they gave us. Now, we also know if the center's at the origin, we know some useful things. We know that these things are both zeros, right? So we can just put x squared and y squared. So we have x squared plus y squared equals 1. We already know a is 6, so a squared is 36. So all we need to know here is b squared. Well, please remember the formula that I gave you earlier, that c squared equaled a squared minus b squared. And so if we know c is 4, then c squared is 16, a squared is 36, minus b squared. So let's just solve that, and we need b squared. So we're going to subtract off 36, subtract off 36. That gives us a negative 20 equals a negative b squared. We can make both of those positive, and we don't need b. We need b squared in the formula, right? So b squared is 20. Plop your 20 up in here, and there's the formula for that ellipse. You don't need to draw it. You just need to write the formula. And this entire thing, just like that, is what's going to go into varsity. Okay? The last question is similar. They give you a little bit different information, but I want to see if you guys can think outside the proverbial box, like this box right here. All right, so that should do it. Toodaloo for now.